All right, for people who are joining this live stream, we are talking about language design around array processing for Wolfram language. So we had met about a month ago and had a bunch of, I thought, pretty good ideas that centered around this idea of I thought we had a better name for this that I had suggested after that meeting, for this thing that was, maybe it's threaded, this thing that is an externally visible wrapper that causes functions to thread themselves in different ways. Did that make sense to everybody?
Yes.
We know what we're talking about there. So, what was the final name that we? Oh, I see. Threaded was the name that you were suggesting here. Okay,
yes.
So we have two different kinds of approaches. One kind of approach is from the outside. That is, you've got a collection of arrays and you've got a function, and you want to tell the function. The arrays themselves do not identify what they want to have happen, but you are telling it from the outside, I want to apply this function to this sequence of elements and this sequence of arrays. Is that correct?
Correct, yes. So this is the idea put forward in this notebook, the external approach. And at the end, there is a connection to threaded.
Okay. Okay, so, but wait a second. So the thing we're talking about is, the first step is, you've got certain, this is very much like tensor analysis with tensor contractions and so on. You've got a collection of tensors, arrays, whatever, and you have a function, and you want that function to take, axis 7 of array 1 and combine it with axis 4 of array 2 and produce a combined array that has been kind of knitted together along those axes. Is that correct?
Yes, correct. So
okay.
What we were discussing is something like, if I have a list of vectors and I want to add another vector, it would be the second level of the first array, the first level of the second.
Right, but this is from the outside, as opposed to the threaded mechanism, where what you would do is you would say, threaded of the vector you want to add in plus the list of vectors. And then the threaded thing would automatically know that it's going to put itself into that collection of vectors, right?
Right. So I think at the very end, I have a value which does the connection. We can perhaps go there and see. Okay. We will explain.
Okay.
Yes.
Here.
So exactly this. Exactly. So you see how
do
we
I
have.
Do I need to run a bunch of other things here? I need to make a bunch of other definitions, don't I?
I think the section called code probably is the thing you have to run.
Okay. That still seems compatible deep dimensions queue. Doesn't seem to be defined.
It's just in the next line.
Oh, okay. Okay. All right. So what are we looking at here? We're looking at.
Yes. So I think let us explore this value in the previous line. So if we have an arbitrary function f, with arrays on the left, some threaded in the middle, and some other arrays on the right.
Mm-hmm.
Then what I'm suggesting is that we could have an extension of map thread which takes negative levels, and what this is doing is just saying, oh, thread the arrays at the deepest levels. It's like, if we have arrays of vectors, it will do the threadings on the vectors, irrespectively of the depths of the arrays themselves.
Right. Right.
Yeah. The only check is that all these vectors need to have the same length, of course.
But so what this is doing is, it's the opposite default. A listable function for us right now threads by default at the highest level. So for example, to do the example here, a current listable function like plus will take, if I say AB plus CD, we all know what that does. But if I now say XY ST plus CD, that's what it does, right? As opposed to what we want it to do with threaded, which is if I said plus threaded CD, then what I would want this to produce is X plus, let's see, what do I want this to produce? Actually, in this particular case, it's doing the same thing, isn't it? Or am I confused? No, I'm confused. Sorry. We want to say x plus c, y plus d, s plus c, t plus d, correct?
Correct.
Right. And you can do that if you replace actual plus with lowercase plus, because listability breaks. Listability is applied before up values.
Okay. All right.
Right.
Okay.
That's the example on the left.
Okay. Wait a minute. I've got a problem here. Hold on. Something is wrong with my file system. Could somebody? Oh, this is bad. My file system is just hanging completely. Great. Could somebody contact Roger?
Yeah, I'll let him know.
This session is now frozen because my file system is frozen. Well, we can talk, but nothing else, so somebody else will have to share. But, yeah. Okay, so I can't scroll this notebook. But what you're saying is, in this case here, what you're doing is you've implemented threaded, but we can't actually implement threaded because of the order of listability. Correct?
Right. Attributes are applied before up values, so it would thread before.
Okay, so I mean, there's an implementation issue here about dealing with this, but what we're trying to understand is the concept.
Right.
So.
Right, and well, I mean, do you have any examples with more than one threaded in them? Because that is sort of what one of. I mean, I think when you have more than two arrays, it's potentially ambiguous as is. But certainly, if you have more than one threaded,
yeah. Right, exactly. So listability already has that ambiguity, and we've lived with it for a third of a century with limited problems. But I agree, if you put two threadeds in there, what's it going to do?
It's going to execute them in order, one by one.
Okay.
And so that will decide what happens.
As in from left to right?
I guess so.
Hey, Roger, I assume you logged into this machine, and can you tell me what's going on with the file system, please?
Well, I just got notification of this, and I'm not exactly sure what's.
Okay, I'm trying to save something out from Wolfram Desktop, and it's just spinning. Right. Okay. In other words, it's trying to access the default. Okay. All right. Onward. So go ahead. What were you saying about multiple threaded stuff?
Yes, we were discussing the order in which this would happen, and I guess it's left to right, but it's decided by the evaluator.
Okay. I think that's as reasonable as it could be. I mean, if you just say threaded plus threaded, presumably that's pretty straightforward. But if you say thing plus threaded plus thing plus threaded, I mean, for example, if there are different default sizes, if one of them is size 3, if you're threading size 3 vectors in one threaded and size 2 vectors in the other threaded, will it go to the level that last matches that particular size? Do you understand what I'm saying?
Yes. So what I implemented here wouldn't do that. This starts by saying, are all the arrays at the deepest level compatible? And only acts if that's true.
Is it obviously wrong to say, go to the level at which it's compatible with the threaded? I mean, that's what people would want most of the time.
But I find it a bit unpredictable. It's the sort of thing in which you are using 2x3 matrices and doesn't work, and then you use 2x2 and that's a different thing.
I understand. That's not super desirable. Okay, I'm gonna kill this, but this is not going to work here. I'm giving up on Roger fixing this, so I'm just killing it. Oh, wow, that's exciting. Refuses to die. Brilliant.
That sounds like a network file system issue, right?
That's what I think it is. That's why I asked Roger to look at it, but apparently he's not producing anything. So yeah, this isn't even dying, even though I'm telling it to, even though I did force quit, and even though the application is no longer says it's running.
We'll try opening it again.
Maybe we'll have ghost windows left over. I've never seen that before. I thought the application owned the windows.
Well, you could also open one of your other, it looks like 6 or 7 Mathematicas.
Wow, this is a pretty interesting operating system problem.
Usually when I've seen this, I've had to either restart completely or at least go to Finder and restart the Finder because there's something in the there should there's something stuck that needs to be unstuck.
Yeah.
Why don't you try opening a different Mathematica?
Well, I'm going to try and kill the Finder. Except I can't even figure out how to do that.
It's Command Option Escape.
Okay. I killed the file. That was, oh, look, but Command Option Escape still thinks there's a Wolfram desktop running, even though.
Well, try force quitting it from there.
I am. Oh, wow, look at that. It all disappeared. Well, let's try it again. I think it's going to fail again.
Jose, do you have this notebook handy? Maybe it would be better if you share for now. And
I can, yeah.
Yeah, okay. Go ahead then, share.
Okay, do you see my notebook?
Mm-hmm.
Okay, move this away. Yes, so I evaluated these same things. So these are the examples we were looking at. And yeah.
Right, so we see x plus y, I mean a plus x, b plus y, right? So we've replicated the xy across all the levels.
Exactly. So this is a deeper level, a deeper case in which we have an array which is 2 by 2 by 2, and with thread also at the deepest level. And so these are there are 3 arrays. So here we have the vector, here we have a 2 by 2, and here we have a 2 by 2 by 2. So we are threading at the dimension, the deepest dimension is 2 in all cases. Now, there is no, we can thread also several levels. So for example, here we are threading an array. It's like map thread can thread at level 2. So we can also thread here. It's like the deepest level.
So actually, sorry, just a quick question. I thought there was also, like last time we talked about, didn't we have a second argument for threaded if you wanted to thread it at different levels?
Yes, we did.
Yes, that's not implemented here. So, I mean, for example, when we say here, when we say map thread level 2, it's threading the first 2 levels, not just level 2. The same thing could be done here, saying map thread -2. It would thread the 2 deepest levels, not just level -2. But I think it can also be done.
Right. So, right, the implementation we have here is doing it at the deepest levels. We don't really have a design yet, I think, or an obvious implementation for at arbitrary levels. I mean, this is a pretty quick mock-up. I'm not saying it would be super hard. I just don't think we've necessarily thought that through.
Right. I mean, I think last time we had some implementation, like I think I I wrote something quickly that was like using just map, and but I think it's probably equivalent to this.
Right. So I think the key idea is rather than counting from the top, is counting from the bottom of the array structure. And so a nice example, which is where the ideas come from, is quantity array. Quantity array is doing this deep threading already. And so this is an example of replicating quantity array, but using threaded. So for example, if we have this array of magnitudes, of a 2 by 3 by 2 array, and we have a pair of units, we are going to thread this pair of units with this level. And so what we just do is to put thread here. And this automatically, because it threads at the deepest level of max, does that, which is equivalent. So this is the proposed extension, which would be threading these two arrays at the deepest level. And so if we do quantity array of max comma units, like this one, and normalize, we get exactly the same result. Right. So this is an application of a case in which we are not doing simply plus, it's just some other function.
Right, which is actually very neat. I mean, it gets rid of a whole class of, I mean, what it seems like it basically does is it lets you use listability on functions that aren't listable.
Or with a different listability, because quantity is listable, right. but I mean, listable in the first argument only. Yeah.
Right. So like it lets you both make functions listable that weren't, and it also lets you control in what ways they're listable and how the listability is matching up and so on. So it's very neat.
Right. Okay. So I think
I'm still debugging my computer, but can you repeat that?
Yeah. So we were discussing this example of which is an example different from using plus, which is the example we have always been using. So we have a magnitudes, an array of 2 by 3 by 2, and a pair of units. And we want to thread this pair of units with this level, with the third level. So we just do this. So let's evaluate again. So we just do this. And so this is the threaded form. This will be the...
Oh, I see. That's very nice. Yeah.
The extension. This is something that map thread cannot do yet, threading at level -1. And then what I wanted to show is that this is exactly what quantity array is doing inside. It's storing the max and the units separate. And when it normalizes, it threads. And it gets the same result. It threads at the deepest level.
Very nice. Okay, so look, it seems to me that threaded is a winner. So let's go back up to your map thread discussion.
Yes, so this discussion here is a discussion of the extension of the function. So this is an implementation. So this is first a way of showing that what map thread does can be done with this extension, this general function to perform threadings. And so, for example, threading 3 levels of these arrays, and these numbers represent their dimensions. So these 3 is threading through levels 1, 2, and 3, which must agree on dimensions 2, 3, and 4. So this is represented in this case by saying thread the first and the first, the second and the second, the third and the third. And then this is the typical F and G discussion, the F function, the first argument of outer, and then this is the G discussion, like the contracting function, like we use
for inner.
For inner, exactly. This is exactly like inner, F and G.
So wait a minute. So what does inner not take level specs?
Only for the first array. Yes, there's an asymmetry here. So inner, we can do F of A, B, C, D, and then 1, 2, 3, 4. And so by default, let's put a G here. By default, it will do that, which is contracting the second level of the first with the first of the second. And we can control the level of the first. And so, sorry. Yeah. So these will do exactly a slightly different thing. So in this case, it's contracting the second level of this with the first level of this. And here it's contracting the first level of this with the first level of this. So we can control the level, the first level of this, but not the level of this one. So that would be, I don't know, perhaps a nice extension.
Right. So right now it only accepts integers in that fourth or fifth argument. Is that true?
Yeah, I could probably accept a list of integers to specify what to do in different. But it's still, inner is not going to work because it's a binary operator, basically.
Right. Yeah. Yeah. So this object, which is now also added to the Wolfram function repo, takes the general function f as in outer, a list of arrays as in map thread, or in flattened form as in outer. Then this is the specification of the contractions you want. So each of these vectors needs to have the same length of this, and you say the level of the array you want. And if you don't want that array to participate in the contraction, you put a 0.
0.
A 0, yes. It's a random thing, but it's a specification of I don't want that array to be participating.
What would be the natural thing? You want it to participate as a whole lump. So you want that array to be treated like it is a single atomic thing. Is that correct? By not participating in the threading operation. In other words, if you take that array, if the array wasn't list, if it was something different.
Well, no, here everything needs to be arrays.
No, I understand that, but I'm saying, what does it mean to not participate? Doesn't it mean that you're treating that array as atomic for purposes of these operations?
Yeah, so let's see if I can.
Well, not really, right? Because it doesn't participate at all as opposed to being a lump.
But what is it? But it gets fed in as f of something, doesn't it? What actually happens to that array?
So let's try to see some example. 1, 2. What am I doing here? And A, B. And now, so the simplest case would be, I want a contraction of the first level and the first level. And right, so this is doing this. So now if I say, do not have the first array participating, then it's doing this. So
hold on. What's that doing? What does that mean? So what did that just do? And why are there double list brackets for that third argument?
Right. So we started with, okay, so let's put a G here. So that's going to be clear. So we started with a list and a list. So the outer form would be a matrix. And so we are now, one of the levels of that matrix is being contracted with G. So if we do this, we just have that. It's the full array. This is outer. So you can imagine that this operation is first you do the outer, and then you do the contractions marked here. And there can be even no contraction whatsoever, which is this case. Right? So this is outer half.
So you're saying you can have a list of contraction pairs?
Yes. I could. I mean, if this was a matrix and a matrix, I could contract one and another one.
But then you could have, the reason there's an outer list bracket is because, I mean, and probably there's an elided syntax where you don't have the outer list bracket if there's only a single pair, right? If there's only a single pair, you shouldn't need the outer list bracket.
You mean like that?
Yes.
Yeah, I'm not sure it works, but it should. Yeah, it works.
Okay, fine. Okay, but fine. But so the point is that it is like the, for tensors, it's like the summation convention. You're making a list of the pairs that you're going to knit together, correct?
Right, exactly, yes.
Except it can be more than pairs. It can be triples and things as well, right? If you had 3 lists at the beginning there, you could have f of 3 arguments.
Exactly, so I can do a contraction of 3 here, right. And all of them are.
So can you copy that input and change one of those ones to a 0?
Yeah, let me see what that looks like. Okay, what on earth happened here?
So this array is not being contracted. So the AB nature of the thing is preserved. So you see the list with an AA and the BB is preserved. So we can preserve now the inner one. and now it's A that is repeated. So
I see. So what it means is, I don't think 0 is the right thing. I think it should be none or something like that. Probably. What should it naturally be? What is that index? That index.
Right. So basically, it's an index that remains uncontracted, right? So the 101 means you have an ABA somewhere in your indices, right?
Mm-hmm.
Yeah, I think I'm using this because this internally is a packed array. There could be many, and then I wanted it packed, but that's the only reason.
Okay. But conceptually, what should it be? That is specifying the level number at which the contraction is happening. So none would be the correct way to say there isn't a level number. Don't contract this, if I'm not mistaken.
Yeah, I think so.
Okay. All right. Fine. Okay. So I mean, this looks good. What's the problem here? This looks like a good thing. And I mean,
no, nothing. I'm just explaining. My construction of map thread is based on this, so I'm just explaining how this function works.
Right. I mean, I think the main problem is implementational, right? I mean, this is sort of a top
meeting. Yeah, right.
This is a top level naive implementation, which is perfectly fine.
Right, but so long as once we know that we really want it, then we can worry about more internal implementations.
Right.
Could we compare it to net map thread operator?
I think you need to down arrow into it.
Okay, sorry. So what do you... Yeah.
Ignore the associations. That's just because net layers have to have inputs are all named. So the associations there would be replaced with a list N1, N2, etc.
Okay, so is your belief that this does something very similar to Jose's map thread, or is this something that does something very different?
I don't know.
Okay, can we look at details and options? Boy.
The relevant note is actually right next to the cursor. So it says it maps the network at level that's the maximum of those things by replicating those inputs that have less than that.
Right. So replication is a closely related operation here. And I think I had a comment here because there is this other function generalizing map thread in that directions too. The idea of replication. So this is not looking at negative threading, but it's looking at replication.
So a couple of questions here. In the case of the generalized map thread, what would it do on associations?
I mean, map thread itself should work on associations and it currently doesn't.
Is it obvious what it should do?
I mean, I think it's very obvious what it should do.
So it should thread the corresponding keys. Is that correct? If you have two associations and you say map thread.
Well, no. So there are actually two ways in which associations can be involved. One is at the top level. So that list of arrays could also be an association of arrays.
I'm not sure I agree with that.
But the other one is a list of associations, which I think is more useful. Right, an association of lists is one thing. And in that case, the natural thing to do would be to say when in the threading specification, to make the threading specification be an association so it can refer to different, to the disposition. No, I'm sorry, every sublist in the threading specification becomes an association in that case. Am I making sense?
Right. I mean, what might make sense here, and I'm not quite sure. This is I haven't thought all right. right, that, you could have a pound1 sort of function, right? A pound A and pound B sort of function, right? That
Yes, you could.
Yes, so that is the
but,
natural.
I mean, right.
go
But
ahead.
when we've talked about sort of generalizing map thread to have an allowed heads option, then we've right.
Oh, okay,
The outer list is always a list, and then it's just the inner heads that need to.
Right. But when there's a
Okay.
generalized map thread with its threading specification, one could have been referring to different arrays by their keys rather than by their positions. That again
Right.
seems somewhat uncontroversial. Yeah.
Yeah, those keys wouldn't play any other role, actually.
Right. They're just referring to, they're just a way of essentially locally naming those tensors.
Yeah.
Okay. But so did this work?
This has worked already. Yeah, I didn't know.
Okay. All right. Fine. So
That's
then if that function f, could you try the hash a and the no. What are you doing? What are you doing? No.
So I was trying to see whether it requires order. Yeah, it does.
Okay. All right. Okay. So now in there, put in the f.
Mhm.
Can we make that f be hash a?
Yeah. Okay.
Yeah, you could just do hash A plus hash B, but
Yeah. Fine. Try it.
Uh,
Try it. No. F of a hash a. It doesn't matter. Hash a hash. Yeah. Hash b comma hash a. Just so we see it do something non-trivial. Hash b, f of hash b comma hash a.
Okay.
Okay. Ampersand, obviously.
I'm sorry.
okay, so it
Right, so
actually
it's fed the naked arguments. So it's basically, well, I'm not,
yeah,
it's basically
I don't
doing the
think that should be
values.
what it does.
Well,
should
in this
preserve
case, this
the-
is correct.
the
You'd want
keys.
it. You'd only want it to do this if there's an association on the outside and lists on the inside, wouldn't you?
Why isn't that being fed in the final knitting? Could you evaluate the line before, please?
Yes.
That one there.
Good.
Okay. So
Because look, the first one is combining the two A's and the second one is combining the two B's. So of
Oh,
course
yeah,
there
yeah.
shouldn't be a hash A and hash B. It
Oh,
would
yeah,
only be if
you're
you have
right.
the association on the outside.
you are right. You're right. Okay. So this is all right. So another
But
question.
the case where the association is on the outside should work like that. But I don't even think that ever works.
You mean
Well, I
this would be an association?
So yes, yeah, exactly. That's an association, and then maybe the inner ones are lists just to make it a little bit easier for it. But I don't think that usage exists, but I could be wrong.
Well, I'm not convinced that it should, because I think it ropes us into a direction we don't want to go.
All right, I don't think it's the most important thing, but okay. So what do we need to figure out next? And actually, I'm going to switch to a different computer in the hopes that I can actually get back into a more appropriate form here. I'll be right back, guys.
So I don't think the external head here plays any particular role.
Right. But if it were in general, it doesn't. But if it were an association, you could imagine it doing something like what we wrote down below with hash B and hash A, right? So like if it was an association with A goes to list 1, 2, and B goes to list AB.
Oh, I see what you mean now. Yes, yeah. I see what you mean. So this is selecting which of these arguments I see.
Right. I mean, it's unclear if that's what you want, but it's behavior. I mean, I think that would be the consistent behavior if it did support giving it associations like that.
Right. Yeah, I think you're right.
There might be weird ambiguities though. Well, I was thinking there might be weird ambiguities if you had deeper structures of associations, but I have to think about it.
So I think with respect to map thread, we have discussed 3 independent generalizations. One is negative threading. The other one is automatic replication. and the third one is having different heads.
Right. So you could have a list of Fs, say.
Sorry?
I'm saying by different heads, meaning you have a list of Fs or a list of Fs and Gs, and you're allowing to descend into both F and G. I'm just expanding on what you mean by that third kind of generalization.
Yes, yes. I mean that for example, here we are threading at the level 2, but we are forcing that both heads are lists. We could have list and list, and then G and G, and it could still be possible to thread. So as long as the heads are consistent per level, should be threadable. And that's where allowed heads might play a role.
This is a random question, but I mean, is there any particular reason why these functions like map thread and I think transpose as well care about key ordering, or like care that the keys are in the right order?
Well, just because, I mean, the implementation we have is of ordered associations. I mean, it was a decision to make, and so lots of functions care that keys are in the same order. Right, they're not same queue.
Right, but I mean, like you can imagine. I mean, right, that there is a little bit of ambiguity, and like if I give you them in different orders, what order do they come back in, and the resulting association. But 99% of the time, you don't really care. Yeah.
Mm-hmm. Right. I'm just saying map thread is not unique. I mean, like transpose cares. Lots of, because we implemented these as ordered objects. I mean, perhaps we shouldn't have, but we did. So
well, no, right. They are ordered objects, right? But I'm just saying that there are a lot of functions like transpose or map thread, which probably could ignore them, could ignore the ordering, but don't. Right, because there are functions like, lookup, of course, ignores the ordering. I mean, well, actually, that doesn't really mean
for a while we had these things without ordering, and it was unbelievably confusing. People thought it was a bug every time they got back. Because they were using the association to store a piece of data, and they got back something that was in a different order, and they were totally confused. So the case that was most confusing was the pure no-op case, where they just typed in an association, the association came back and had been reordered.
But you don't want to. No, right. That you definitely don't want to do. I mean, associations are ordered, but you'd want to do something like use the ordering from the first association or something like that.
I see what you're saying. Yeah, why not? Right, like show. I mean, so what is the case that you're talking about? You're saying that it refuses to work if the map thread refuses to work if the ordering is different. Is that correct?
Yeah, and similarly with things like transpose and lots of functions.
Yeah, that's probably wrong. I mean, arguably, we could even have an option that determines whether it should allow the possibility of having reordered associations, because you might, for safety, want to make sure that they are all in the same order. But it seems to me that it should allow reordering.
There's also, by the way, one step further. Sorry?
Sorry, I just was going to ask whether there is a function that can impose the order of one association on another, so that you do it first.
Well,
that's a good question. Would key take a second association?
No, but it'll be key take and then keys.
Yeah, I know that, but that's a good idea. That there's some kind of conforming. I mean, there is a notion for machine learning of conforming one array to another.
Actually, sorry, I just checked. So it looks like key union reorders the associations to all have the same key orders. It's actually the second example. Yeah. So this actually key union also has the extension I was going to mention, which is one step further is also that if the keys don't align at all, you add missings, which key union does.
Yeah, that's a good idea. All right, let's. I hopefully I'm now able to actually run things again, so I could share. I had unfortunately, it would be nice if it was the case that the thing that basically took over my computer had discovered something interesting. It hadn't. It was just hundreds of rogue kernels. Okay. So the proposed extension of map thread we basically believe in. I mean, do we want to go over more details of this? And the concept of threaded, did we have another concept that we were also pushing for, or these were our concepts? Implicit threading, explicit threading, that's what you are now calling generalized map thread, right?
Yes.
Okay, so let's go through.
I mean, the generalized map thread, I think, is a subset of that, I think.
So I'm not proposing a different function. I'm proposing to extend map thread to take negative levels.
Yeah, I understand. Okay, so that's this case of explicit version. Then what is this? Constant array replicates levels of an array. I'm not quite sure what's array replicate here. And then there's the headdress form of array reduce, right? Which is, can we try to remember what that is about? Remember what that is about?
Do you mean what, array reduce or?
No, the headdress form of array reduce. So level applied, right?
Mm-hmm.
So what that's doing is it's saying on this array, apply f at level. What the heck is this doing?
So I guess that's equivalent to array reduce f, array, 2.
I assume, but I'm now forgetting how array reduce works. Let me remind myself how array reduce works. Go ahead.
I wrote some tentative examples for array reduce because I was also trying to get a better feeling.
I actually have to go, so bye.
Bye.
Yes, I remember now. So I think the way I understand now array reduce is that it's a combination of first flattening and then mapping.
Okay, so array reduce is the concept of, for example, presumably you have this example immediately here, right? Are you sure you don't want to give this with a symbolic matrix? This assumes people can do arithmetic very easily.
So these are examples from Etienne.
Okay. Well, but so this particular thing, every row of a matrix, why is that reduced at level 2? Is that the surviving level or what? Reduces dimension n of array by applying f. I don't understand. Why does it do that? Why does that mean?
Yeah, so the level, you name here the level that disappears, the level that is being, so here we have a 3x5 array. And
but so what? The level 2 is oh, wait a minute. Wait. My mouse is jumping around on the screen. No. For God's sake. Okay, hold on. Let's see, we are in, where were we? Functional programming, array processing. I guess SW notes too. Okay, now you're going to explain why this makes sense. Why array reduce?
So I was saying that the number 2 is referring to the dimension that is going to disappear. So we are taking the mean of vectors of length 5, which are in the second dimension. So it's a different way of looking at it.
Wait a minute. Why are they in? Okay, hold on. This thing here is this thing.
So that's
I see. I was confused. This is really confusing. This should not be used as the example. We should not have this be a matrix like that. That's really confusing. You understand? Because it's the second. Here, it's obviously the second index, right? Here, that is not obviously the second index. At least not to me. Do you understand what I'm saying?
I understand what you're saying. Yes. Yeah.
I also think the example is wrong because I think we should be doing this example here, where we can explicitly see what it's doing there, right? We don't want to use mean where you have to compute it in your head. Do you understand what I'm saying?
Yeah.
I mean, so can you change that example?
Yeah.
And you're complaining at the wrong person. I mean, we can change this, but right.
Yeah, I understand. So it's okay. It's okay. It's all right. Okay, let's change it because that's not an understandable example. Okay. So let's loop back to what we're trying to figure out. So to me, okay, we had the headdress form of array reduce. That was the thing we were talking about here. Apply F at a particular level.
Right.
And that's a different thing from all the threading business because threading is a multi-array story, right?
Yes.
Right.
So
go ahead.
Here we have flattening too. So the important thing in array reduce is that there is this combination of flattening and mapping.
Okay, but it's a single array operation.
Yes.
Okay, so can we look at level applied, please? Because that's a headdress for, F. So level applied F, 2 would be the equivalent of array reduce F onto this thing. So the idea would be that this here would say apply F at level 2 in this thing here. Now, what's the difference between that and apply? I'm now very confused. What is the difference between map F at level 2 onto that thing?
I would say that if we want an operator form of array reduce, we could implement it in array reduce itself because it takes 3 arguments.
I was just going to ask, is there a 2-argument form of array reduce? I mean, why do we need a new?
I don't think so.
Yeah, well, okay, fine. So that's then a headdress. Okay, so although I do like the idea of kind of a apply it to the columns. I mean, so this would be, the whole point would be to be able to have code that says something like level applied mean, 2 of an array. Would that be right? That would mean apply to the columns.
Well, it's
not exactly apply, right?
But apart from that, if you evaluate array reduce F, we have it in the example you wrote above. It's applying to the actual rows. So I'm not sure it's the same notation we need.
Okay, but what we were trying to deal with here is, okay, what is the minimal way to take a matrix and apply an operation to its columns? Is it array reduce, 1?
I think so.
And why is it 1 again? Aren't columns at level 2? Aren't columns the index at level 2?
Because this is referring to the dimension it's going to make disappear. Not so it's just a different convention.
Okay, but that to me is, the thing that I think I want often is I've got this array, a data set, for example. Let's take a data set, and I want to, at a certain level, and that could be a named level, and we'll come to that in a minute. This could be, I want to do this operation on this level. Does that make sense? I believe it makes sense. So I'm taking every piece at that level, and I am doing this operation on it and replacing that level by the thing that is that. Does that make sense, or does that not make sense? Because every deeper level is then contracted out.
I think it makes sense, because the key idea in array reduce is that before you map, you actually transpose that level you are interested to the bottom. So it's clean. And then.
But so let's imagine that I have a rank 3 tensor. Okay. So I've got array A, let's say 2, 3, 4. Okay. Now I want to, what does it mean to apply F? What would level applied? Okay, so let's imagine we had level applied F, 2 of that array. What would that mean? What would that do?
Right. Well, I mean, it's not apply in the sense of apply bracket, right?
Fine, but just tell me what you think this should do. I mean, what's the natural thing for this to do? Does it make sense? Or does it not make sense? Because once you put the F around it, it's no longer an array at deeper levels.
It does. So array reduce can do this. So let's try array reduce of this array. So f comma this array, and then actually 2. Try that. So now do dimensions of this. Right. So you see how it ate the second level.
Yes. Yes. But let me ask another just question. I mean, in terms of displaying things like this, is there a more reasonable way to display these things? I mean, something like table form has a way to do this, if I'm not mistaken.
Yes, though not everybody can read these things.
No.
I think it's pretty hopeless. Okay, in the modern world, given that we have interactive ability to display things, what should we use to display high-rank tensors? Is it basically dataset? Is dataset the appropriate? I mean, let's take a look at what the dataset display mechanism would do for this.
It could be. So matrix form helps a bit more because it has the parentheses. So it's able to orient yourself a bit.
Right, but these are just matrices, right? That's not going to make a huge difference. I mean, what I would do is I would replace the A in array with subscript of A, comma, pound, pound.
Today's point was matrix form works for things that are not matrices, and it uses nested parentheses to indicate that. And it's actually.
I don't understand what this did. What the heck did this do? Why am I not seeing a rank 3 object here?
Because it's putting everything together. So the lines have different meanings. So try matrix form.
Why doesn't it at least have heavier lines between the ones that are at different levels?
It should.
Okay.
Try matrix form. I think it's the clearest we have.
Okay. Matrix form works for deeper.
Yes.
Yep. Yes.
Okay.
Yeah. So at least here you see clearly that you have a matrix of vectors.
Isn't it a vector of matrix? Oh yes, matrix of vectors.
So you go it's like mod 2. You go matrix, matrix, matrix until you end up with something that is not a matrix.
Right. So what did this do? This made. Okay, this isn't bad.
A matrix of matrices.
This is what dataset should use, for its display, except without parentheses.
Right.
In some way, and I don't know exactly, probably if we made each of these things, if we framed these things, what would happen? Is there a way of putting frames in?
Yes. And actually, that's interesting. That's what I do in Exact, for example. I put horizontal bars too, to distinguish a matrix which is 3 by 1 from a vector.
Okay. Oh, wait. So hold on. So I mean, can I actually write the code to do this? What would I do to put a framed at every level here? Is that am I basically saying map all of framed onto this?
Well, that'll go into the Fs too, right? That's
There are no Fs, there are As here. But okay, let me make this simpler. Let me just do this. Oh God, what the heck is this?
No, so yes, so remove the all and map framed at level 2. Sorry.
At level 2, like
list
this.
2, yeah.
What did that do? No, I want to map at level 2 and level 3, I think.
No, I think we need a combination of framed and matrix form. So we need to put matrix form inside frame.
Right. Ethan is complaining on our live stream that our functions like map thread and so on should do more. We are making them do much more. The problem is to keep them so that they are somewhat understandable, so we don't have to spend half an hour understanding what they actually do. But so basically what you're saying is that array reduce is a single array thing which is doing something unachievable by map thread, correct? Or is array reduce a one argument form of map thread, basically?
They are different because array reduce contains flatten inside, and flatten can do lots of things that map thread cannot.
So is there a generalization of map thread that also does flattening?
So there are 4 fundamental operations on tensors, which are just separated: outer products, transpositions, contractions, flattenings.
Okay.
And so these are the 4 independent fundamental ones. And so array reduce is some sort of derivative of flatten. And that's why it has this final.
Right. I mean, it has a couple of transposes inside of it, but.
What is flatten in the world of tensors and general relativity? What is flatten? Does it exist?
It's a bit like combining indices. Like when you say, I have a decomposition of 2 spaces and I'm going to do a 2 + 2 decomposition. So you are going back from the 2 + 2 to the 4.
Right. Okay. Fair enough. Okay. So, all right. So it seems to me, okay, so an operative form of array reduce seems to make sense to me. I wish it wasn't named quite that way. And you're telling me that my level applied thing, are you telling me
well,
that?
I don't know what your level applied thing wants to do.
I think the use case that I'm most interested in is the endless array of do an operation on a column. The endless different versions of that.
Where by do an operation on a column, you mean f of the list formed by,
I suppose I do.
Yeah,
and then it depends a lot on what that returns, whether it returns a list or whether it returns a single object or whatever.
Right.
But maybe we could come to a different question, which is this question of named levels. Okay, because that's something within data set, for example. Okay, right now, levels are always just positionally indicated. It would be very convenient for data set and for many, many other things if levels could be named. Am I making sense?
Yep.
Okay, so what is the analog for, just as an association is to a list as a blah is to a nested list, right? So one could imagine some kind of thing that's called I don't know what, nested, I don't know what it would be called, but an association, to remind ourselves, is something where we have taken, okay, so what would it roughly look like? What we want to do is we want to say in this matrix, A, B, C, D, we are, okay, let's just imagine that it was called level named of that comma X, Y. Okay? There was a wrapper, a level named wrapper. Okay? And that then operations that normally specify a level. Now, if we said go down to, so it might have the same relationship. Like if I say 2 here, that does extract the C. So in other words, there might still be a numbered level that corresponds, even though we've said for convenience, there's naming, just like the keys in the association for convenience give naming, but there is still a raw level here. Am I making sense?
Yep.
Okay, so the question is, what would level named be? What would it how would that work? So level named would be able to take, if you said data set of level named, then what would happen is that the data set, when you, let's take a random, where's the random data set? We've got example data, data set, the planet data set. What is it called? Is it called planets?
Planets, but you need a list. It's list dataset, comma planets.
Okay, so let's imagine that we could name these levels. So this thing in, so there's a level here. This is one level that has that set of keys. This is another level that has this set of keys, right?
Yes, and then we have 2 more.
Right.
So these are 4.
Case. Right.
Yeah.
But so imagine that this was, so if I were to do a normal on this, it'll be a big complicated mess. Okay. But then if this was a level named object, see, one issue is you want a kind of a global level named. You don't want to spray. I mean, okay. So the other issue we know we have, okay, is the spraying of the fact that we have row-oriented storage. We don't have a way to share the keys across similar rows. Am I making sense?
Yeah.
Right. So we know that we also want, and I guess we're doing this for data set, a version of data set in which the keys are shared. Right. Is that correct?
I'm not sure. Why would we want to share? Oh yes. And I understand what you mean. Yes.
Right.
Can you explain to me? Because I'm not sure what he means.
Yes. So the idea is that when you have a data set with columns, with headers, the keys are replicated in all rows. So we want a way of having.
Right. We want to save the storage associated with, and other things associated with the fact that we're repeating mass, radius, moons over and over again.
Exactly.
Right? Now, I don't know whether that is top level accessible to people or whether that just magically happens. I mean, it's kind of an analog of a packed array, for data set, if I'm not mistaken, right?
Mm-hmm.
And I think that's something that's being worked on, right, Jose?
Yes, and I know that there is the image processing team is particularly interested in this. Yeah. Mm-hmm.
Okay, but are they working on it actively?
They have their own. I think they call it data frame object internally.
Okay, which does this, which is what we can use for data set, right?
Right.
Okay, well, fine, but then that object. So this thing here, level named, we could imagine having something where we have a syntax where at every level, every time we say A, B, C, D, right, we're annotating, right? Just like we could re-annotate the keys here. We could say list, X goes to A, Y goes to B, right? We're repeating those keys. See what I'm saying? We could imagine a similar repeated keys version of named levels. So I'm saying, basically what's happening is, look, here's how you do it. You would put a headdress around. Okay, so let's say we say, okay, this is how we do it. We'd say named level list level X of named level list comma Y AB named level list comma Y CD, right? That would be the explicit form, just like the explicit form of repeating keys in the association.
I see.
Right. So in principle, we could do this even now. We could put a headdress form of list where that could be ingested by dataset just the same way that list and association are ingested by dataset. So what I'm saying? So then here, this would be a convenience labeling, just like in associations, keys are convenience labeling, but there's still a raw part number that's left there. Right? In this particular case, with this way of doing it, we would have to do nothing more, because so long as you weren't doing head operations, so to speak, this would just work. Right? In other words, the old level numbers, the old integer level numbers would still work, but now all we have to do is to have something which does, if you say level Y, it has to find level Y.
This assumes you have been careful to name the same level consistently.
I know. It's just like in a data set, right? If I didn't have this, if I had this with a Z goes to C, and I made that into a data set, it would no longer align, if you understand what I'm saying.
Yes, but I guess I'm complaining about the name. By calling it named level,
it's a bad name. It's a bad name. If you've got a better name, suggest it. I'm just right. I mean, I'm just saying this is the explicit form. This is the implicit internal form. I mean, in which you might want to use. I don't know whether you want to use it. This is a form. I mean, this might turn into this. It might spray these things in here, and it could be the case that syntactically what would happen is, okay, that this says ABCD, okay, and I don't know if this is going to work, but let me try it. If I do this and I say control whatever X, control whatever Y, it's kind of inelegant, but you see what I'm saying. So something roughly like that.
Mm-hmm. This reminds me very much of indices in tensors, when we have the array and then we have a wrapper around it and we say with indices ij. And so I helps you to go to the first level and j to the second level.
How does that work with tensors? Explain.
So imagine that you have something like, let's invent something like indexed. Well, no, indexed we have already.
Tensored.
Tensored, yeah. Invent some word. And then we put an array in the first level.
Mm-hmm.
Yeah, metrics, and the other one, yeah. And then because that's level 2, we have a list called ij, which are the two indices of this object.
Mm-hmm.
And now this object will represent with the whole matrix as usual, perhaps in matrix form, with the subindices ij. And now, for example, if we do a transposition of this, we return something which is ji.
But the original matrix is the same. It's just the ji is different. So
it has been transposed. So if we transpose the object, we transpose the matrix, we move the indices. To remember, we have transposed it.
Okay, so wait a minute. This is basically explicit tensors meets implicit tensors. Is that right?
Yes, if you want, yeah.
Because an implicit tensor is something like, Tij or something is an implicit tensor.
Right.
And the transpose of Tij is Tji.
Right.
But this is saying, so explain
So let's imagine that we want to check that this tensor is symmetric.
Mhm.
Right? So we transpose it, and then we would get tensor of ACBD.
Okay. Just to understand what it does. Yep. This followed
Right.
by JI.
But JI.
Okay. So in other words, okay, so that's exactly what we would get up here. Naturally, if we transpose this, it would take the labels would be carried around. Right? That's the natural thing to do here.
Mm-hmm.
Okay. So, but this is, your tensored is pretty much the same as my level named. Is that true?
Yes, I think so.
Okay. But the main, okay, so what are some examples of things we can do? So in dataset with our weird query language, right? What we're doing with the weird query language, so, dataset queries, for example, right now we're saying dataset, and then we do an operation that is the axis 1 operation, then the axis 2 operation, and so on, right? So the obvious thing to be doing would be something where we say, we have an association and we have an axis name, and then we have an operation, right? Is that right? Tally, you probably have opinions about this.
If you're talking, you're muted. Oh, we seem to have lost Tali, I think.
Hopefully not a scheduled power cut in South Africa or some other bizarre thing like that.
Yeah, I don't see him in the meeting anymore.
Okay. Well, okay. Sandra is pointing out. Yes. I mean, Sandra is pointing out that what you could do with tensored or level named is you could say, map F onto level named blah, 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 comma, X. And that would indeed map at on the X, on the level named X. Right. That's the idea. And then with data set, you would say, do this operation. So instead of having to do the weird thing where you have to say, right now, you'd have to say data set all, comma, F. You see what I'm saying? To do an operation on level 3.
Right.
Whereas what this would be doing is you'd be saying something more like, I mean, I don't know whether you can do this. Maybe you can already do this. Maybe it has some weird syntactic thing where you can already do that to do an operation at level 3. Is this making sense?
There is a notation like that, but I think that 3 means position, not level.
Position
So
what?
In the level you have. In this case, it will be the first level.
Okay. Well, okay. So, but in any case, this would mean, this is again some kind of level applied thing of. This isn't quite right. I mean, this is again, if we had level applied, right? We could say level applied fx to data set, which means apply f at level x. Although it might be sufficient to just say apply f comma x data set. That might actually do it. Or at level x, for example, like this. Right?
Well, with the full form, we don't have an operator form of apply with 2 arguments. But
right.
I see what you mean. So it would be really nice to have in the data set the 4 levels named planets, planet properties, moons, moon properties.
Exactly. That's the point.
Mm-hmm.
Do we have anybody here from the image processing team who knows about this data frame concept? We have Jerome from machine learning. Do you have a comment on this? Nope. Okay. Move on.
I think I would prefer to not make the same, I mean, the same problem that we have with data set of replicating. So if we can keep the levels kind of separate at a very high level in data set, I think that would be the most flexible thing.
Well, what happens if you extract something? Okay, so the question is, I mean, okay, so this is named levels. Let's say that you have a named thing like this, for example, right? Or so we have this, or we have level named of, you know, ABCD. XY. All right, so let's say we've got, this is called LN, for example, okay? So one thing we might want to do is extract, we would normally say part number 23, 221, let's say, okay? But we want to be also able to say LN of essentially part, well, here's what we would want to do. We want to say extract from LN. Okay, does this make any sense? You see what I'm about to do?
I see what you're going, but I wouldn't do this for general expressions. It would be something in dataset. So dataset knows about level names, and you can extract from datasets, and you extract other datasets that keep the level names corresponding to the thing you extracted.
Why would you not do it for anything with level named? Just support that as a construct that things like extract could deal with.
Yeah, but why not have level? I mean, the part of level named, if you did, you know, part of that too, it could give you level named of the second part, comma y. It could keep the names when it's not down to the elements.
It could keep the names, yes. Right. No, I mean, that's what I'm proposing, and that's what it would do naturally. In other words, if we had the concept of an as if sprayed form, you understand what I'm saying? That everything is as if it was this. It isn't in fact this, but it's as if it was this. See what I'm saying?
Mm-hmm.
So you know, so it's okay. So now the question would be okay, what other operations would do interesting things with level named? So transpose of level named, you're saying, and I don't completely understand this, would both transpose okay, what would flatten do for level named?
So the names would be combinations of names. So you would have for example,
that would be weird, right? Because with flatten, you can combine names, levels.
Right. So it would have to be the combined level. So that would be, you know, in a sense, flatten of level named would have to be something like, boy, what would it be? It would be, I mean, it would have to say something like, you know, level named of, and then it would be this with this thing flattened out.
Right.
Then the second thing would be some kind of combined level wrapper.
Yeah. So, or a list.
Well, I don't know whether it can be a list because it would already be a list, but it could be a sublist possibly.
Exactly that thing. So now there is a single level named list XY.
Mm-hmm.
So maybe I missed something, but with transpose, why can't we just store a permutation instead of transposing both the names and the expression?
We probably could from a storage point of view, yes. Okay, but so what about other operations? What would be, for example, array reduce? Clearly, that would be a prime user of this type of named level idea. I mean, look, named levels are obviously a good idea. The question is, what, you know, can we imagine what would be involved in implementing these, and what's the, you know, is this the right conceptual way to think about them? I claim that it is.
So my worry here is homogeneity. So arrays have consistent heads. If you don't have consistent heads, then we are in the trees world.
Mm-hmm.
And so in a sense here, what we would have is a first level of a tree called X, and then having two children, and we could have Y1, Y2. And now we wouldn't have really an array because the two heads are different, but perhaps it still makes sense in some tree approach.
Okay, but I mean, look, the basic point is for us, at the user level, an array is a list of lists for us.
Right.
By putting in this named level thing, we are making it a more integral object. Right? I mean, right now we don't have I mean, it would be nice to be able to have something where you can extract pieces of it and they would come with their level name. In other words, it's a way of annotating, just like, okay, association has been a huge win because it allows one to basically annotate one's it's much better to have, rather than just the list 4, 5, 5, 6, 7, right? If we can say name, rank, whatever, right? It's much. It is a good way of annotating data, right? So
Right.
this similarly is a way of annotating data. It's like in the planets data set, what does each level mean? And to my mind, you do want to be able to carry that around.
I see. What about a level in which the level is an association itself? So do we have some sort of named association?
No, but I'm saying you headdress in this conceptual view of it. Everything has a level name headdress.
Yes, but what I'm saying,
association.
But we cannot wrap association, right? Because association is atomic. So what would
can we really wrap list? Okay, this is a conceptual thing, right? We're introducing a wrapper that would have to be somehow transparent.
I see.
Right, because otherwise, named list. I mean, if you take eigenvalues of this thing, right, it's got to work. Even though these are somehow named level lists, and I don't know, right? So, I mean, it might be that implementationally we introduce it first in something like dataset, but I'm saying I think it's useful as a concept for, okay, again, let me remind you that currently when we take this and we take the normal, take this as normal, we are spraying, masses and radii for every planet. You see what I'm saying?
Yep.
Okay. So I'm saying take the analog of that it is as if you were spraying it into each of these heads. Right? Now, in practice, it might be stored much more efficiently than that, just as dataset, hopefully in the future, will store things much more efficiently.
Let me. Okay, so I'll first say it's not entirely clear to me I guess I sort of understand, but it's not at all clear to me how this would work. But my other comment is going to be, right, we introduced packed arrays in 2002 or thereabouts, and there are still bugs with, things not handling packed arrays.
Right, okay, this is an implementation issue. I understand.
Wait, hey, let me finish my sentence.
Okay.
Right, so, this is, right, this is significantly more complicated than packed arrays. So, you're talking about a multi-year project, just as long as you're aware of that.
I understand. To put this in everywhere is a complicated project. Yes. But we should figure out where we want to go, and then we figure out perhaps first step is to put it into dataset.
Yeah, I think so. It would be very nice to say something like map on the moons, for example, in the planets dataset, without having to worry about which level it is.
Exactly. Right. But so, it could be the case that data set contains a level name, but we don't yet have sort of naked level names.
Right.
Okay.
Mhm.
But the whole point is that and I mean, data set is a simpler case because all of your issues about raggedness don't occur there. Because data set is simply a sandwich of lists and associations.
That doesn't mean it can't be ragged.
No. I mean generalized raggedness.
Yeah, it only supports
generalized raggedness. If in this expression here, I could have written, I mean, let's call it level raggedness or something, or head raggedness. That's what I'm talking about, right? I'm talking about something where you go A, B, G of C, D. Right?
Yeah, so the data set case is simpler because it's only lists and associations. That's clear.
Right. But so what it would take within data set, how would you enter a data set? Okay, what would happen when you say normal of a level named data set? Would it lose the labels?
I think so.
Probably has to. Okay, so then going into data set, what you would do is you would say data set of this thing here, and you would say something like, it's not the right name, but level names arrow XY here, right? That's how you would set it up.
Yep.
So we're only going down, allowing, maybe that only makes sense, right? But isn't this assuming some level of rectangularity, which you're certainly not guaranteed in a data set?
No, that's the whole point. The whole point is this is the point about head raggedness, right? Data set cannot be
it's not head raggedness, right? I mean, like
no, this doesn't care whether this is CDE. It doesn't make any difference. It doesn't care about that. It's only naming. Think about these level names as being head decorations, right? They're decorations for the heads on level 1, decorations for the heads on level 2, and so on.
Right. So E is still at level 2, even though this is not rectangular.
Yes. Right. It's purely decorating the heads, or AKA the levels in this case, because it isn't the case that in a data set you can't do, I suspect, the following thing. I don't think I can do AB and then say X1, Y2. I don't think that's a valid data set, is it?
Well, it will be considered a row of two things, I think.
What the heck did that do?
Right. See.
What did that do?
Well, it's doing better than I was expecting, but I mean, it's a valid set in the sense that data set can take lists and associations and
okay, that makes sense. That makes sense. And if I put another copy of that association there, okay, that seems right. Okay, but there's no problem with the named levels for this thing.
Right. So the difficult thing is to read back the I mean, if you had to reconstruct the internal structure of the data set from this output, it wouldn't be easy.
Right. I mean, I just, right. So I can't claim to have completely thought this through, but I can tell you from personal experience, right? I click down and I see some new square of values. I mean, you're not seeing it here, but like if you, like the planets data set, right? And I'll see a different square in them. And so I'm not sure, like,
No, but
is
so in this case,
NASA named level or not?
no, it's not a
No.
named level. It's an association. It's a key in an association. This is a named level. So this is planet properties is a named level. Mass, radius, moons. That's a named level, right? So at this level, the level up first here is planet properties,
Okay.
right? So the label of this layer is planet properties.
Okay, so Venus is at the level of planets, and then we have
Mass is
planet
at
properties.
a planet property. So what we could do here is in this breadcrumb, we could annotate, planets. No, that's the planets level. This is the planet properties level, right? So we would annotate the breadcrumbs.
Right. And okay, so go right. So I guess that quantity there of its mass is at the planet it's below planet properties, but that's of course not going to be homogeneous because some properties might be themselves compound.
Yeah, in which case there's different level. Look, specifying. Okay, your point is if the thing has fingers that reach down into subsequent levels in some parts of the data set, but not others, there might be some things that would have labels X, Y, Z, and other ones that would just have labels X, Y.
Yes.
Okay.
That's what I was trying to say and said it very poorly.
Okay, right. I understand the issue. So then the question is, if you say apply to level X, well, we have that issue already with data set. Right, we have the issue already. So, see what I'm saying? There's a question. Right. Okay, so there's level raggedness. Head raggedness is one thing. Then there's level raggedness.
Right, and I get.
And what data set does right now? I don't actually know what data set does right now with level raggedness. I need to get going here.
Okay, something for us to think about for next time.
I don't think I don't think there's a problem. I mean, the problem already is in map. So if you have something ragged and you say map at the level 3 and not everything has level 3.
Yeah, then it just doesn't do it.
It maps what it can. It maps on the things that are at level 3. It doesn't bother about the rest.
Mm-hmm.
By the way, Ethan is complaining about the fact that dataset doesn't support out-of-core operations. We are working hard on that. Also, the fact that query gets too complicated. I agree. We need essentially a query builder. We need some kind of code assistance mechanism around query, and that's again something that is at least in active discussion and something we probably should actually somehow we should merge some version of this meeting with the code assistance crew and try and talk about that at some point. Make sense?
Yeah.
Okay. All right. Thank you, everybody. I need to go. And for those paying attention, I'm actually doing we're doing 2 more live streams today. Oh my gosh. Another at the top of the next hour, I'm doing a Q&A about business and innovation. And we're doing another design meeting at 4:30 Eastern time. No idea what it is in other time zones. And I need some lunch, and I'll see you guys later.